Record third hour, yeah. Okay, my B is what? That's right, 4. My slope is 1 over 2 or -1 over -2, right? Okay. So I'm going to graph that line. It crosses my y-axis at 4. It's my y. There's number 4. If I use this one, I have to go up 1 to the right 2. If I use this one, I'm going to go down 1 to the left 2. Then, highly suggest you use a straight edge. Want one? See Brandon. Okay. Draw a straight line.
That was before your empire.
Okay. Because you didn't use a straight edge, did you? All right, second one. Okay, my B is 1. My slope is, now this time I had the negative out in front of the fraction. I could put that negative with the numerator, or I can put it with the denominator. Okay, thank you, Brandon. It crosses my y-axis at 1. See, if I use -1 over 4, that means I have to go down 1 to the right 4. If I use 1 over -4, I'm going to go up 1 to the left 4. And lo and behold, it actually crosses intersects at this point right there. But I'm going to draw a line to make it visual using my straight edge. You need a straight edge, see Brandon. And my solution is exactly 1 point. Remember, I have 3 scenarios, right? Exactly 1 point, no solution, or all solution, infinitely many. This one I have exactly 1 solution, which is the point, see, -4, comma, +2. So that took me, what, 2 minutes? So last night your homework was 4 minutes long. This is review. Solve by substitution and solve by elimination. Those are the 2 other methods. Okay, solve by substitution is exactly what that means. You have to, first of all, you have to get what? Variable by itself. Doesn't matter whether it's the x or the y. You have to get a variable by itself. Or isolated. Okay, problem number 3. Do we have an isolated variable? Do we have an leave him alone, he's sleeping. Do we have an isolated variable? Yes, the y is by itself. The y equals -2x plus 2. Okay, you take what y is equal in this equation and you substitute it into wherever it is in the other equation. I highly suggest that you use the parenthesis method on this. -3 x minus 8, here's my y, equals 10. And what does my y equal? That's right, negative 2x plus 2. Now all I have to do is what? Solve for x. Reason why we do this method is to solve for one variable only. So I have negative 3x, negative 8 times negative 2x, positive 16x, negative 8 times positive 2, negative 16. Be careful. These are, well, you could, but I like to combine like terms first. You could, more than willing, that's fine. Okay, add 16 to both sides. I get 13x equals 26. So what's x going to equal? 26 divided by 13? 2. Okay. So, yeah, I have, because I got x equals a number, that means these lines are going to intersect, and it's going to intersect at the point where my x is 2. Now, I have to find my y. Yeah, pick an equation, one of the original ones. I'm going to pick the bottom one because that looks like it's easier. Y equals 2x plus 2, negative 2x. And I know my x is 2, so I'm going to substitute that in. So y equals negative 2. My x is 2 plus 2. Y equals negative 4 plus 2, or y equals negative 2. This is my answer. Yes. Should we do another? Yes, Mr. D, let's do another. Let's do number 4. Okay, let's do number 4. Do we have a variable by itself? Yes, we do. We have y by itself, so I'm going to take what y is equal to and substitute it into the other equation where the y is. So I have negative 8x minus 3, my y I'm going to substitute in, equals negative 23. My y happens to be negative 4. Negative 4x plus 13. You a junior? Are you a junior? No? Sophomore? Sophomore, right? It's showing. Okay, negative 8x, negative 3 times negative 4x is positive 12x. Please don't forget the x. A lot of you on your quizzes forgot the x. Negative 3 times positive 13, negative 39, equals negative 23. And the rest you solve however you want. I combine like terms first. Gives me 4x. No, this is our note sheet. Add 39 to both sides. for x equals 16. So what does x equal? So again, we're going to have a point where my x equals 4. All right, pick an equation. I'm going to pick the top one again. Or not again, but I'm going to pick the top one. Is it -3? Yep, -3. Okay, they intersect at the point for -3. Sorry, it's your homework. Any questions on solving systems of equations by substitution? Okay. Last method that you learned and that we're going to use is solving systems of equation by elimination. Hey, what do you think of when you hear the word eliminate? Exactly what teachers would like to do with some of their students, right? Eliminate them. Get rid of them. So we want to get rid of a variable. And the way we do that is we're going to add these two equations together and somehow eliminate either the x's or the y's. Now, if I do that to this problem, will it work? Will one of them go away? No, it's just like some students, they just won't go away, right? All right, so we have to multiply one of them by a number, or maybe even both. All right, so we look at, this is what I do. It's kind of like the order. I look at whatever one is a positive and negative. Well, that's negative, that's positive. So we could use the x's. That's negative, that's positive. We could use the y's. Yeah, and then what I look for next is, are any of these coefficients a factor of the other in the other equation coefficients? So, and indeed, on the y's, 3 is a factor of 9. So I'm going to multiply the bottom one by 3. And again, since we have different signs, I don't have to worry about multiplying by -3. So, distribute. 3 times 7x, 21x. 3 times -3y, -9y. 3 times +6 is 18. And we're not doing anything with the top one, just bring it back down. So I have -8x plus 9y equals 21. Now when I add these together, one of the variables eliminates the 9y's. 21x plus -8x is 13x. 18 plus 21 is 39. Don't you think it would be nice if I can get rid of students that easily? Just multiply them by somebody else. Okay, divide both sides by 13. So x equals, which means I have exactly one answer with x equaling 3. We got to find y. Back to the original equations, pick one.
Bottom.
Yeah, I'm going to pick the bottom. 7x minus 3y equals 6. My x is 3. 3 times 7, or 7 times 3. minus 3y equals 6. Subtract 21 from both sides. You guys are experts at this by now, right? So what's y? So these lines intersect at the point 3, 5. Yes, let's do number 6. What a great idea. Thank you. Thank you for suggesting that. Okay, which one do you want to get rid of, the x's or the y's? Any particular reason? Why? Okay, so you're right. It's not going to matter which one we get rid of on this one, because both of them have opposite signs. The 5 is not a factor of 9. The 3 is not a factor of 8. So I have a lot of students that like get confused. Like on the first one, which one should I multiply by what number? One way you can do this, and you're going to have to do it with this problem, just choose a variable you want to get rid of. Say I want to get rid of the y's. Okay? What you do, now you could do this with any elimination problem. If you choose the variable you want to get rid of, just multiply each equation by the coefficient of the other. So this coefficient is 3, this coefficient is 8, so multiply the top one by 8, and multiply the bottom one by 3. This will always work. Now the numbers may be bigger, but it'll always work with every elimination problem. Okay? So let's go ahead and distribute. 8 times 9x, 72x. 8 times negative 3y, negative 24y. 8 times negative 18 is negative 144. Okay, 3 times negative 5x, negative 15x. 3 times 8y is plus 24y, and 3 times 10 is 30. Now, when you add these together, if you don't have a variable that gets eliminated, like Mr. D would want to do with some students, you did something wrong. 72x plus negative 15x. Let's see, 7, 6, 57. Negative 114. Hey, look, 57 is a multiple of x equal negative 2. Be careful. So we have exactly one point where the x equals negative 2. Okay, pick an equation. Okay, I'll pick the bottom. My x is negative 2. Negative 5 times negative 2 is 10. Subtract 10 from both sides. So you get 8y equals 0. And this is where some students say, hey, I can't do this anymore because you get 0. No, 0 is a number, okay? Divide both sides by 8 to get y by itself. Y is 0. Okay? They intersect at exactly one point, and that point is negative 2, 0. Now, you have quite a bit of time left. Normally, I would do the application problems.